time for square root inequalities. I know you're so excited to have more inequalities. So this one is a little bit different than absolute value inequalities. Different things to take into consideration. So first, let's look at a pretty basic one. Let's say we have square root of x is less than 2. So if we look at this graphically, remember you can graph things like this by graphing two separate y equals. So you have your y equals square root of x and y equals 2, and where those two things cross would be the solution to your equation. This is an inequality, so slightly different, but same type of idea with graphing. So if I look at my graph, I know what the square root of x looks like. I know it starts at 0, 0, 1, 1, 4, 2, and 9, 3. Okay, and then if I look at y equals 2, that's this line right here. Alright, so if I were looking for where they were equal, that would be pretty easy. It'd be right here at x equals 4. But I'm not looking at where they're equal. I'm looking at where is the square root of x less than 2. So where is it less than is all of that space on this graph that's below this line. So it's all of this. And it stops here. Why does it stop there? Because the graph of square root of x stops there. And you can only go as far as your domain will allow. Remember, we talked about how domain and range are very important in algebra. It tells you what your solutions can and cannot be. So here it only goes to 0. So if we were to actually write this as a solution, I know that x is greater than or equal to 0 and less than 4. Now how did I know what these symbols were? Well, this is less than because it can't be equal to 2. It has to be less than 2. So that's this symbol here. And then I said it had to stop at 0 because that's where the domain of our parent function stops. But it can actually equal 0. If I were to plug in 0, I get square root of 0, which is 0, and that is less than 2, so it works. And that's why this one is included, but this one is not. So with square root inequalities, your symbols aren't always going to be the same like they were for absolute value inequalities and some of the other ones that you've dealt with. Now this one was pretty easy to graph and tell from a graph. But as always, equations get more complicated and sometimes they're more difficult to see from a graph. So if we take a look at this equation, square root of x plus 5 minus 1 is greater than 6. Well, I've already graphed the left side of this, square root of x plus 5 minus 1, using all of my transformations. Where is it greater than 6? Well, 6, if I look on the graph, it's way up here. And the square root function is pretty slow growing, so it's not just going to jump way up here to 6. It's going to take a while before it gets there. So this is one where knowing how to solve it algebraically would be a lot easier than trying to do it on a graph. And if you had a graphing calculator, you could still do it there, but you're still going to have to change your window and do a lot of guesswork. And personally, I hate messing around with the window trying to guess it where things are, and it can get kind of annoying and frustrating. And sometimes it's just quicker to solve it by hand with algebra. So let's take a look at what to do. Now, as you might guess, you treat this slightly like absolute values in that you have to isolate the parent function. So we need to isolate this square root right here. I'm going to take the 1 to the other side. So I have square root of x plus 5 is greater than 7. And now that the square root is by itself, how do I get rid of it? Because I can't get underneath the square root until the square root is gone. So to get rid of a square root, you square both sides. You're doing the opposite. And what you do to one side, thou shalt do to the other. So when I square the square root of x plus 5, I just get x plus 5. cancels out that square root, and you're just left with what's inside. Square 7, and I get 49. Now it's pretty easy algebra. Subtract the 5, and I get that x is greater than 44. I don't know about you, but I don't really want to draw out 44 tick marks on my graph or have to deal too much with the window on a calculator. So this would be quicker for me. Now if we look at this answer versus the answer we had on the first problem, they're different. The first one was a compound inequality, and this one's not. So why was this one not a compound inequality? Well, it's because we didn't have domain restrictions to deal with. There was nowhere where the graph stopped. Okay, so you have to take domain into consideration. Now what we could look at is domain restrictions on this equation. So domain is what can x be. So if we think about where x is, it's under the square root. And what do you know about numbers that have to be under the square root? They have to be positive. So that means that if I look at my domain here, I know that x plus 5 has to be greater than or equal to 0. So it must be positive. And then I can solve here. So x has to be greater than or equal to negative 5. Well, if x is greater than 44, it's automatically greater than or equal to negative 5. So I don't have to worry about that. Generally speaking, the only time that you have to worry about your domain restrictions is if you have a square root where it's less than something. So if square root is less than, then be careful about your domain restrictions and make sure that you have a compound inequality. Don't worry, we'll do another example. Let's look at 3 times square root of x minus 2 plus 3 is less than or equal to 15. So again, I'm going to isolate my square root. So 3 times square root of x minus 2 is less than or equal to 12. Divide both sides by 3. So I know that the square root of x minus 2 has to be less than or equal to 4. I'm going to do 2 things here. I'm going to solve the equation as is, and then I'm going to look at my domain restrictions. Okay, so domain, again, is taking that inside part here and saying, okay, I know that this has to be greater than or equal to 0. So x has to be greater than or equal to 2. Has to. No matter what this other part says, x has to be greater than or equal to 2. So now I'm going to solve this. I'm going to square both sides. So it's going to give me x minus 2 is less than or equal to 16. Add 2. So I have x is less than or equal to 18. And then I have this x is greater than or equal to 2. To make sense of this, number lines can be helpful also. So I have 2, I have 18. So I know that it's less than or equal to 18. So all of that. And I know that x has to be greater than 2. And your answer is that wonderful spot where both of those overlap. So this right here is my answer. Compound inequality, x is between 2 and 18. Ding, 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 ding. Answer. So, with square root inequalities, do a little bit of recap. First, you want to isolate the square root. just like with absolute value. Then square both sides. Then you're free to solve for the variable. Figure out what does x equal. And last, if you have square root is less than a number, then you have to solve for your domain restriction. That's going to tell you what the bottom part of your inequality is, the inequality of your solution. So you'll end up having something like this. And obviously this could be equals to, not necessarily, actually that is equal to. Be equal to, or it could just be less than. Okay? That's only if a square root is less than a number. Let's look at a couple of special cases.